Use the given 0 to find the remaining zeros of the function. Our function is h of x equals 3x to the 5th plus 5x to the 4th plus 138x cubed plus 230x squared minus 441x minus 735. And we're given that this polynomial has a 0 of negative 7i. So the first thing I notice is the degree of this polynomial is 5, so it should have 5 zeros. We are given one of those zeros to be this complex number, negative 7i. So it makes me think maybe we'll use the conjugate pairs theorem. So I just need to check to make sure all of my coefficients are real numbers, and they are, so that means that the conjugate pairs theorem is valid, and we have a second 0 of a positive 7i. That's the conjugate of negative 7i. So because we have zeros of negative 7i and positive 7i, I know that this polynomial will have factors of x minus 7i and x plus 7i. So I'm going to multiply these together and try to reduce the polynomial that we have. So I'll multiply this out, and that gives x squared plus 7i minus 7i minus 49i squared. This is x squared. The plus 7i and minus 7i cancel. I squared is negative 1. So we have x squared plus 49. And I know that this factor of x squared plus 49 will divide into our polynomial, reducing it down for us. So I'm going to use long division. X squared plus 49 divided into that polynomial of 3x to the 5th plus 5x to the 4th plus 138x cubed plus 230x squared minus 441x minus 735. And I'm going to try to match the leading coefficient, or the leading term here, with the leading term here. So I can multiply 3x cubed by the x squared, and that would give me 3x to the 5th, and 3x cubed times 49 would give me, I think, 147. Let me check. 49 times 3 is 147. And let me write that 147 underneath the cube. 147 x cubed. I'm doing that so I line up my like terms. So then I want to change the signs to subtract. The 3x to the 5th minus 3x to the 5th becomes 0. I will carry down this 5x to the 4th. And 147 minus 138 is 9, and I'll have a negative 9x squared here, and I'll carry down these terms. So then I repeat that process over again. So now I'm trying to match this 5x to the 4th. So I will multiply by 5x squared. 5x squared times x squared is 5x to the 4th. And 5x squared times 49 will be 245x squared. And I'm writing it under the x squared, so I have my like terms lined up. I'm going to change the signs. 5x to the 4th minus 5x to the 4th is 0. The next term comes down. Negative 245 plus 230 would be a negative 15x squared. And we'll carry down these terms, minus 441x minus 735. Now we repeat that process over again. So I'm trying to match this leading term, negative 9x squared. So I need to multiply by, I think I made a mistake there. So let me highlight my mistake and correct it for you guys. So right here, this was a cube, and I changed it to a square. So I need to change that back to a cube. And this is also a cube here. So I would multiply that by a 9x, negative 9x. So negative 9x times x squared would give me negative 9x cubed. Negative 9x times 49 would be a 441x, and that would be negative. I'll change the signs. Negative 9x cubed and 9x cubed will become 0. Carry down this next term, negative 15x squared. Negative 441x and 441x become 0, and I'll carry down this next term here. So repeat one more time. Now I'm trying to match this coefficient here, and I need to multiply by a negative 15. Negative 15x squared, and 49 times 15 will give me 735. That should be negative. We change the signs, and we get our remainder of 0 that we expected. Let me zoom out a little bit so you know where we are. So our polynomial, h of x, we can factor that using our two expressions here. That's x squared plus 49 and 3x cubed plus 5x squared minus 9x minus 15. And we want to try to see if we can break down that 3x cubed plus 5x squared minus 9x minus 15 more so we can find the other zeros. So let's focus in on that, the 3x cubed plus 5x squared minus 9x minus 15. So one of the techniques that I try with cubic polynomials like this is grouping. So I group two terms at a time together and factor the greatest common factor out of each group. So for the first group, the 3x cubed plus 5x squared, there's a common x squared that I can factor out. And that would give 3x plus 5. The second group, negative 9x minus 15, has a common 3. And I'll factor out a negative 3, and that'll be leaving me with 3x plus 5 as well. Now, if this grouping method is going to work, what's in the parentheses here should match each other, which it does, so that method is going to work. So we're going to factor out that common 3x plus 5 and be left with x squared minus 3. And I'm going to be able to set each of these factors equal to 0. And this will help me identify the remaining 3 zeros. So I subtract 5, that's 3x equals negative 5, divide by 3. Here I'm going to add 3 and get x squared equals 3. Square root both sides and get x equals plus and minus square root of 3. So we've got now all of our zeros, because this is a 5th degree polynomial, it has 5 zeros. The zeros are negative 7i, 7i, negative 5/3, and positive square root of 3 and negative square root of 3. Thank you for checking out my videos. Have a great day.